Hi, this is the second chapter of our let's say content or book, and we will mainly start discussing about probability, guys, this time, and then we will be talking about some basic terminology, and then we will jump into the probability function and probability density, random variables, rules for probability, conditional probability, laws of probability, and independence. So these are very important aspects, and I would like you to get involved in these topics in this video. So if you look at the basic terms that we will be talking in this part of the semester or in this part of the course, we will talk about experiments. Okay, experiments are repeatable procedures. Like I am flipping a coin. I am choosing something from a sack. I am rolling a die. Okay, these are like experiments. Okay, well-defined possible outcomes. I know if it is gonna become heads or tails, if it is gonna be 1, 2, or 3 when I roll a die. Okay, the possible outcomes are well-defined, and I can repeat this process. This is called experiment. The set of all possible outcomes becomes the sample space. For example, uh, for um, for flipping a coin, the possible outcomes are heads or tails. Okay, if you remember, heads is written like this, arkadaşlar. Heads, and it is called in Turkish tura. Okay, and tails, and this is called yazı. Okay, heads and tails. For example, if I roll a die, okay, die means zar, okay, die. If I roll a die, the possible outcomes are 1, 2, 3, 4, 5, 6. This is like sample space. Okay, we denote it by omega or S. Out of this all possible outcomes, if we say I am only interested in 2 heads when I flip a coin 3 times, that becomes the event, okay? Like a subset of the sample space. I am I'm flipping a coin 3 times. This is my sample space, and the event will be like 2 heads, okay? So this is an event. If I talk about probability function, this function will give me the probability for each outcome. For example, for flipping a coin, either I have the heads or tails, okay? So the probability of obtaining heads is 1 over 2, and probability of obtaining tails is 1 over 2, okay? So this will give me the probability. For example, if I have a die, it has 6 let's say sides, and then each outcome has the probability of 1 over 2. Okay, probability of obtaining 1 is 1 over 6. Probability of obtaining 2 is 1 over 6. So we will talk about these as probability function. If I'm using these probabilities and drawing them, and then now I will have, let's say, this kind of a distribution or this kind of a distribution, okay? These will be the probabilities of events. This will be the probabilities of events. And these will be the possible outcomes, okay? Possible outcomes. So it might be, for example, this is like tails, heads for a regular, let's say, coin. The probability will be 1 over 2. Okay, for rolling a die example, we will have 6 possible outcomes, and probability of each of them is 1 over 6. Okay, 1, 2, 3, 4, 5, and 6. So the probability is 1 over 6. So this will give me the probability density. A random numerical outcome will be called as random variable. Okay, we will use this term very often, and it's a little bit tricky concept, but like here flipping a coin and heads or tails is not a random variable. If I'm after counting the number of heads in such an experiment, then I would say number of heads. When I flip a coin 5 times, the number of heads will be a random variable because it's a numerical outcome. Okay? The number of people entering the classroom, it's a numerical outcome. The number of photons hitting a sensor, a random variable. The height of a person, random variable. Okay. So when we put all these in place right now, we will talk about some examples together. Okay. So first thing, my experiment is tossing a coin, flipping a coin, and then reporting if it lands here, heads or tails. Is it going to be yazı or tura? Heads or tails? Okay. So what is my sample space? The possible outcomes are heads or tails. What is my probability function? Obtaining heads, the probability of obtaining heads is 0.5. Similarly, probability of obtaining tails is also 0.5. Okay. So now I'm tossing a coin 3 times. This will be my experiment. Here are the possible outcomes that I have: head, 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 tail, heads, tails, head, head, heads, tail, tail. All of these are possible outcomes. How many possible outcomes? 2 to the power 3, which is equal to 8. Okay, this is my sample space. If I talk about probability function, obtaining 3 heads will be, the probability of obtaining 3 heads will be 1 over 8. Probability of obtaining this will be 1 over 8. Obtaining each combination, let's say, is going to be, the probability of that will be equal to 1 over 8. Okay. So if I think about a different example, which is different than flipping a coin or rolling a die, for example, we may want to count the number of taxis, the cars, that pass Erkilet Avenue during this course, for example, in this 1 hour. Okay. So how do I do it? No cars may pass during this hour, which is very unlikely. Or 1 car may pass, 2 cars, 3 cars, 4 cars, and it may go up. Okay. 100 cars, 1,000 cars. It depends on the time instant. Okay. So this is my sample space. And in this course, we will see a probability distribution function called Poisson distribution. Okay. This is not Poisson. This is Poisson. This is a French mathematician's name, and it is called, in French, it is called fish. Okay. Poisson means fish. So now we are going to model this experiment using this probability function. This is PK, number of cars passing by or taxis passing by during 1 hour period. This lambda is the average number of taxis, which I know from my previous experience. Okay, previous experience. I know it. I have collected some data for that. Okay, it is like e to the power minus lambda times lambda to the power k divided by k factorial. And how will be my probabilities? The probabilities for 0 cars to pass, I will put, instead of k, 0, and lambda will be coming from previous experience, which will be maybe 10. And finally, we will have e to the power minus 10 times 1 divided by 1, which is e to the power minus 10. The probability of obtaining no cars is very low. Okay, this is the probability value. Probability of obtaining no cars in this 1 hour. Probability of obtaining no taxis passing by during this period. Okay. We will talk about these Poisson distribution, normal distribution, and different types of distributions, binomial distribution, all these in coming weeks. Okay. So I would like to now focus on the events. So event is a collection of outcomes, and it is also a subset of the sample space. For example, if I am flipping a coin 3 times, and I'm interested in exactly 2 heads, I would like to find out what would be the probability of obtaining exactly 2 heads. How can I do this? My event is now explained here. What is my sample space? Heads, 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 tail, and so on. How many such options? 8. 8 possible outcomes. How many of them are exactly 2 heads? You see, heads, heads, tails, tails, heads, head, tail, head, tail, head, head. So I have 2 heads here, okay? So what is the probability of obtaining this event? It is 3/8. I have possibly 8 outcomes, but when I say exactly 2 heads, it is like 3. I have 3 such outcomes. So the probability of obtaining exactly 2 heads is 3 divided by 8. And let us think about some more examples, and I will finish this asynchronous video for you to review. So these are some sample spaces, like discrete sample spaces, okay? They might be finite. We know them. There are only 2 possible outcomes, 3, 5 possible outcomes. And in some case, it might go very towards a high value. Then we would say it is listable. I can list it, but there is no endpoint here. Okay, that's why we call it infinite. Okay, so a discrete sample space might either be finite and listable and infinite. Okay, these are all listable. I can list them. How many cars are passing? 100. 1,000. How many photons are hitting? 1 million. How many passengers are using this? 5 million a year. Okay? So these are listable things. But also, we might have not listable situations, which are called continuous sample space. For example, I can generate a random number, which is between 0 and 1, and it may take any value. Let's say 0.0123, okay? So it is not discrete anymore, it is continuous. It is not listable, okay? There are 2 things here, listable, unlistable, or discrete, continuous. In the listable case, discrete case, you may have finite or infinite or infinite sample spaces, okay? These are some descriptions. Again, as the basic idea about probability concepts, we should also talk about probability of something, okay? Probability of something is always between 0 and 1. There is nothing like 1.1 probability. In some exams, I can see 1.5 or 5 as a probability, which is not possible, okay? Probabilities are always between 0 and 1. And the possible sum of the probabilities of all possible outcomes is always 1, okay? Probability of obtaining heads is 1/2. Probability of obtaining tails is 1/2. So the addition of these 2 will be 1, okay? Probability of obtaining 1 when I roll a die is 1/6, and so on. And the addition of these all possible outcomes will be equal to 1, okay? So we should always bear in mind that these 2 rules should always be in place when we talk about probability. Okay, when we think about rules of probability, we should think about these rules also, arkadaşlar. Like, for example, the C means complementary. Okay, complementary. So if A complementary C, the probability of A complementary C is 1 over PA. Okay, I have this sample space. This is my A event. Okay, what is the probability of A? PA. What is the probability of A complement? Here. Okay, so the probability of sample space is always 1. Okay, I will add all of them. So what is the probability of here? Probability of this is equal to 1 minus PA. The second rule, if there are two disjoint events, okay? Disjoint events means they are not overlapping with each other. So probability of L and probability of R, when I have their intersection or union, if I add the probability of these two cases as a union, then my output should be probability of L plus probability of R, okay, left and right. If they are not disjoint, but if they have a kind of intersection between two, left and right, what should be right? Probability of L plus probability of R minus the intersection, okay? So these are some rules, for example, with the probabilities, and during the class, we will start working on some exercises together. I want you to read, I want you to watch this part on your own and understand these rules of probability. I hope this was a good session for you.